Please welcome Quentin Stafford-Fraser.
Thanks, Mike. Ladies and gentlemen, I'd like to talk about a tyranny that afflicts the IT industry. It's been with us almost since the dawn of the PC, so we don't really think of it as a tyranny. But it has restricted the way we think about computers. It has limited the way we think about delivering information and displaying information. It appeared to offer a standard for interoperability, but in fact has stifled innovation on very many fronts, and it's now largely unnecessary and avoidable, which is why I wanted to call this changing the face of the PC. So what is this terrible thing? What is this shackle we must cast off, this ball and chain that holds us back? It's not Microsoft. No, ladies and gentlemen, as you probably guessed, I am referring to the tyranny of the VGA monitor lead. So I hope you'll forgive my amateur dramatics, but I'm making a serious point here. For most of the life of the PC, computers and screens have been tied together by this bulky, inflexible, umbilical cord, which carries high-frequency analog signals, and so you can't make it more than a few feet long normally, unless it's highly screened and expensive. And there's normally only one place to plug it into the back of your PC. And so we've grown up with this one-to-one mapping between the box that produces information and the thing that displays it. And in the past, that didn't really matter, because displays were great big, bulky, fragile, hot, high-voltage things, and you didn't want more than one of these on your desk, because otherwise you wouldn't have any desk left. And you didn't want to hang them on the wall, if you could avoid it, because that involved major structural engineering, and they had a nasty habit of imploding if you dropped them. And these things were big, and big ones were really big, and they're kind of cubic. So if you want to double the width of your screen, you ended up taking up about 8 times as much office space. And so we didn't really see this as a limitation in the past. And because the display is the main way the computer communicates with the user, it's the basic high bandwidth link into our brains, users were also caught up into this one-to-one-to-one mapping. So we have one user, one computer, one screen, one keyboard, one mouse. That's the way we think of the computer. But all of that is starting to change. Displays are now nice, lightweight things. They're relatively cheap. They use much less energy. They're much less fragile. You can hang them on your walls. You can put them in the window of your store. You can put 4 of them along the back of your desk and still have a desk to work at. And there are good reasons why you might want to do this, because there are lots of studies which show quite a good correlation between the amount of display space you have and your productivity. And if this doesn't seem intuitive, if you think, we talk about the computer desktop, the thing we see on the screen as a desktop. But for most of us, that desktop is about big enough to hold half a sheet of paper. That's what you see on your screen. So imagine trying to work on a real physical desk that was about big enough for half a sheet of paper. And you could scroll it up if you wanted to sign it at the bottom and scroll it down again. If you wanted to look at a different sheet of paper, you would have to do that. If you wanted to switch the pen you were using, you'd have to go into a special tools mode where you'd put your pen pot on top of everything else you were working on, pick the pen you wanted, put it back, and so on. It's ridiculous. You'd never work that way on a real desk. And yet, that's what we do in computing. So pixels are good, more of them are better. The displays are changing, we can have lots of pixels, but we still connect these displays to the computer with the old VGA lead. And so that means if you want to do something like, I don't know, put a display outside a meeting room, which tells you who's got the meeting room booked next, which seems like a reasonable thing to want to do in the 21st century, you often have to plan for the PC that's going to sit on the floor beside it, or that's going to be up in the ceiling. And it's very inconvenient. Actually, there was a lovely example of this in Cambridge in England, where I'm from, in the railway station. And you go in, and there are 3 big plasma screens on the left, And for a very long time, one was arrivals, and one was departures, and one was please press Control-Alt-Del to log in. And I think it stayed that way for about 2 months because to do that, someone probably had to actually climb a ladder with a keyboard and plug it into the computer that was fixed to the back of the display. And this is the only kind of innovation we've had, is that we actually tie displays and computers closer together, and it's a ridiculous place to be in the end of the 21st century. In the 21st century. So this morning, what I'd like to do is talk about the company that we set up to try and deal with this problem, the ulterior motive we had for setting up this company, some of the achievements or otherwise that we've had, and some big picture ideas that have come up along the way. I really want to talk about unusual ways to build PCs and unusual ways to build companies. So a little background, as Mike mentioned, I came through, I used to work for Cambridge University. I went through various commercial research labs in Cambridge, AT&T and Xerox and Olivetti. And this was great fun. We did some wonderful projects until the dot-com economy went and all of these labs closed. And I and all my friends found ourselves out on the street, which was probably a good thing for us. Probably a good thing for Cambridge, actually, as well, because the little companies we went and set up employed a lot more people, actually, than the lab had in the first place. So this is my first suggestion for how to get entrepreneurialism going in your area, is to get a large foreign company to come and invest in your area, employ a lot of your students for 2 or 3 years, and then fire them all. And this is good for 2 reasons. The first is that redundancy pay is a wonderful thing, because for many young people particularly, it's the first time in their lives they will actually have enough money in their bank account to think about what they want to do for the next 2 or 3 months, or perhaps the rest of their lives, rather than just what their employer tells them to do. And the second thing is they will be highly motivated to do this, because if you have seen a project you've put a lot of time and effort into, ending up sometimes quite literally in a skip, you will want to go and make sure that doesn't happen again in future. And I remember a friend of mine over a pint of beer in the pub one night saying very firmly and fairly coherently, I'm never going to write another line of code that I don't own myself, which he probably hasn't done. So this is good. This is one way to stimulate entrepreneurialism. About the time this happened, I made friends with a guy named Martin King, who's based in Seattle. And Martin had come through the dot-com economy a little better than I had. He's the guy behind the T9 predictive text input that's probably on most of your phones. And he had built up this company and he'd sold it to AOL at just the right time. And so he was also looking for projects. And we had various ideas which we threw backwards and forwards. And but the one we settled on in the end was a not-for-profit, semi-charitable organization, which was with the purpose of trying to create a more affordable, more sustainable open IT system for the world. Modest aim. And we called this Ndiyo. Now, Ndiyo is a Swahili word, it means yes. And in Swahili, in general, the emphasis comes on the second from last syllable. So this is Ndiyo. All together? Ndiyo. Very good. You'd be amazed at some of the pronunciations I've heard of this, actually. Mike's was pretty good in comparison. So if you can't remember how to spell it, it's DIY with no around the outside. This is my attitude to life where possible. So, and we wanted to address some of the problems that we saw with the PC-based model of computing. And there are 2 in particular. The first is affordability. So for about half the world, a modest PC costs more than their annual income. So what I'd like you to do is picture your own annual income. Got that figure in your head? Imagine your next PC costs that much. How many would your kids have? When you were a student at college, how long would it have taken you to be able to afford one? How many would there be in each classroom? And if you wanted to set up, say, a new internet cafe where you needed 1 per customer, or a small business where you needed 1 per employee, how big an impediment would this be? It's a real problem for a lot of the world. And the problem is that the PC is actually very good value for money. It's had 25 years of about 1 billion sales, of cost reduction to get to the point where it is now. It's very good bang for the buck, but it's still too many bucks. For a lot of the world, it still costs more than a house. So we needed to find a way to change the economics of owning a PC. The second issue was sustainability. And some of this comes about because of the history of the PC. The PC is a personal computer. It was designed to be the standalone computer, the thing that could be disconnected from the corporate mainframe and the corporate network, so that you didn't have to be subject to the control of all those funny bearded people in the IT department. And so what we did was we took most of the components that used to be in a mainframe and we would stick them into a box that you could have under your desk. And this was a bit of a mess, but we would put a lid on it to cover it all up. And that worked well until we realized that actually managing any number of these things when they were disconnected was a real nightmare. And in fact, most of the interesting things that PCs do comes from when they can talk to each other, when they can talk to other peripherals, and in particular, when they can let users talk to each other in new ways. And so we connected them all back onto the network and duplicated all this complexity for every user. And if you have 1,000 users, you typically have 1,000 CD-ROM drives and 1,000 power supplies and 1,000 sets of memory and so on. And there's a lot of cost associated with that, a lot of inefficiency in various ways. And one of these is in terms, say, of the carbon footprint. So it takes about 1/4 of a ton of fossil fuels to make a PC. Now, when I heard this, I tried multiplying it by the number of PCs that are made each year in the world, and I came up with a big number which I really couldn't visualize. So here's my visual aid. Imagine you had a row of cars going all the way from New York to LA, nose to tail. It's about 1 million cars if they're Ford Tauruses. And now imagine that they're actually 4 abreast. They're taking the whole highway all the way across the country, about 4 million cars. But none of them are moving because all of their petrol tanks are empty. And so you go across and you fill up every one of these 4 million cars. Think how long it takes to fill up your tank. And you do this all the way across the country. It's a big job. From empty to full, 4 million Ford Tauruses. That's roughly how much fossil fuel we use in the world every day to make PCs. And that's before we switch them on. And it's before we dispose of them 3 years later because they're out of date. And in particular, it's the situation when only the first 1 billion people in the world have access to this technology and the other 5 billion are still waiting to get hold of it. So for affordability and for environmental reasons, this can't really be the way to provide IT to the world. And we do need to provide IT to the world because in the past, if you didn't have access to a PC, you probably didn't have access to word processing and spreadsheets. And you could argue that most of the world was probably better off without these things. Whereas now, as we in the developed world become more and more PC-centric, if you don't have access to a PC, you may not have access to photography. You may not have access to recorded music. You may not have access to international news, and you certainly won't have access to all of the new communication media that we're developing around blogs and wikis and chat rooms and instant messaging and Twitters and whatever your thing may be. And so this is what we were trying to tackle with Ndiyo. Actually, there's a nice story behind this name as well, which I should tell you. We used to tell people that we picked this because we were looking for something with an international ring, so we like the Swahili. And we were looking for something that said, yes, there is a more positive way forward for IT, so we like the fact it meant yes. In actual fact, that was a load of rubbish. What we were looking for was an internet domain name. And I had tried most of the European languages I knew for words to call the project, and I couldn't think of anything. I couldn't find anything for which a domain was available. And I was about to call it something silly like Boink or something. Boink was probably taken, actually. And I suddenly thought of Swahili, and I knew a little Swahili because I had been born in Africa. And I typed in the first word I could think of, which was yes. And sure enough, I could get Ndiyo.org, Ndiyo.net, Ndiyo.anything I wanted. And it was only later that we realized we shouldn't be embarrassed about that story because it's indicative of the problem we were trying to solve. Swahili is an important language. It's spoken by 50 or 60 million people in the world, and yet the word yes had almost no presence on the internet. When you typed it into Google when we started, I think it returned about 80 pages, of which most of them were translations into English. If you type it now, they all point at us, so we haven't really fixed that problem, but this was the idea. So, like most good IT projects, it started with a back-of-the-envelope calculation, and I think it really was a back-of-the-envelope, and this is the only bit of maths I'm going to do here. So, what we noticed was that if you take a standard workstation screen of about 1280 by 1024 pixels, and you assume that every pixel on that screen is changing every frame at about 25 frames a second, which is as fast as the human eye can see, just about, that takes something in the region of 500 megabits, half a gigabit. If you wanted to take all of that information and send it over a network. So the first thing we noticed is that if you have gigabit Ethernet, you can just do this. Now, there may be software bottlenecks and things which stop you, but fundamentally the network architecture isn't the bottleneck. But if you take a standard workstation screen and do relatively simple compression on it, something like run length encoding, you find that you actually get about a factor of 5 compression, which means you're down to 100 megabits. And that's when you're assuming everything is changing and you're sending all of it. But in fact, if you only send the changes, then most of the time you just need a very small amount of bandwidth, and you only need 100 megabits or so when you're doing an alt tab between two windows that have lots of graphics in them or something like that. And what that meant was we ought to be able to put a display on the other side of a network from the computer and have it be so fast that the human visual system couldn't tell that you weren't directly connected to the computer with one of the old VGA leads. And instead, you could be connected with nice Cat5 cable, which is much nicer stuff to work with, and you can plug it into sockets in the wall, and you can have as much of it as you like, and it's just much nicer to deal with. And it also meant, because it was going over the network, that you weren't tied to this one-to-one mapping that we've had in the past. You could have a source of pixels going to many displays. You could have software control over which pixels went where. You could do all sorts of fun things. And, of course, you could go much greater distances than you could with the old VGA lead. So we were changing the way that PCs and displays could connect together in fairly fundamental ways. Now, the other thing was that we could put a relatively simple bit of hardware at the other end to take the pixels off the network and decode them and put them on the screen. And that could therefore be very low cost. And if we could find a way to plug a keyboard and mouse into it and have those messages sent back over the network, then essentially very low cost, very high performance terminal for the PC at the other end. It was basically an ultra thin client. I imagine most of you are familiar with the idea of thin clients, where essentially you put the graphics in one place and run the programs somewhere else, and they've had a somewhat checkered history. And I think that part of the reason for this is that they haven't really had the courage of their convictions. They haven't been thin enough. So the way most people make thin clients is you take something that's a lot like a PC, and you throw away the bits you think you can do without. So you get rid of the hard disk, and you give it a bit less memory, and perhaps a slightly less powerful processor, and you end up with something which ought to be cheaper than a PC. But in fact, they're made in much smaller quantities, and so they often cost as much as a PC, if not more. And so you can only sell them on a sort of total cost of ownership basis. And there are very good arguments there, and they definitely have benefits if you're a large organization deploying thousands of desktops. But we felt that you ought to be able to get a lot of these benefits if you're a small organization. If you're a small museum, a family, small classroom, a small business, do you really still need to have one PC per person? Or can we actually do something more interesting than that? The other thing we did was take advantage of Linux and open source software in general. And one of the nice features of Linux and all Unix-based operating systems is that every Linux machine, out of the box, is a multi-user system. It always has been, it always will be, able to support multiple simultaneous users, but in the past we haven't really had good hardware to make that really easy to do. So we thought we could have a lovely combination here of low-cost hardware, free software, multi-user software, and we could change the way we use PCs and break this one-to-one mapping. Not only is there, of course, zero cost for the initial software, but there's zero cost for adding extra users and all the benefits you get of avoiding viruses and so on as well. So we could share a PC between several people. We could share the cost of a PC between several people. We could share the environmental impact of a PC between several people. And we thought this was great. We built some prototypes. We gave some talks. We had some meetings around the world. And then we hit a problem, which was that we wanted to make hardware. And hardware takes quite a bit of money. And in particular, to get the performance and the cost we needed, we wanted to make custom silicon. And that takes lots of money. So what do you do when you want a few $1 million? Well, normally you go and talk to those nice venture capitalist guys. And I was a bit of a fundraising virgin at this point, and I lost my innocence fairly quickly. Because, you know, it's called venture capital. Most of these guys, they aren't really in it for the venture bit. And so we had this problem. We tried, you see, we believed this had great application in the developed world as well, but in general, we were talking about scary things. We were talking about things like Linux on the desktop, which venture capitalists didn't really get. We were talking about scary things like selling things to poor people. And we even tried the time-honored method of getting business people interested in the developing world. You know what this is? You call it emerging markets. But even that didn't work. And so we were kind of stuck. And then one day we were sitting in Martin's office in Seattle when we realized that if we had a good way of sending pixels at speed over networks, you could use it for a whole range of other things other than just trying to save the world. You could use it for the arrivals and departures notices in the railway stations. You could use it as a way to let you put 4 displays along the back of your desk and connect them into your one laptop, whatever it may be. And so, and this was something that we probably could get the VCs to fund, and our ulterior motive was that the commercialization of this would hopefully get this stuff in the quantities and the prices and so on that we wanted eventually to be able to use it in internet cafes in Indonesia. And so we started this company called DisplayLink to do this. Though actually at the time it was called Newnham Research. Newnham is part of Cambridge, where we started this in a garden shed. And we thought this was in a good tradition. And after a while, we outgrew the shed, and we moved into other offices, and we started making stuff. And the first thing we made was this thing, which we call a NIVO. And NIVO stands for Network In, Video Out. And basically, this is what we were talking about. This is a network adapter for displays. And if you feel too geeky carrying one around, you can pretend it's something else. It's nice and solid state. It uses about 2 watts or something. And we started building these things and experimenting with them. And we gave them to various people. This is another not-for-profit organization in Cambridge called AidWorld. They're doing software development for various AIDS situations. They have 5 programmers working fairly hard on one PC. And they've been doing this for about 2.5 years now. Actually, I'm always intrigued by this photo because I think there's a roll of blue paper here, and I think that's peanut butter or mustard or something up there. But in among here, you can see there are some NIVOs, and there's a PC out in another room which is driving all this. You've got 4 people there. There's another terminal in another room as well. And they love this stuff. They're some of our biggest fans, which is great. DisplayLink, on the other hand, was commercializing this, and I've got a couple of little clips here which should show what they were doing.
Because modern displays are so flat and light, we can put them pretty much anywhere we want. But normally this means deploying extra PCs to drive those displays, or using expensive dedicated systems which allow us to send the video signal over large distances. The Ethernet NIVO has changed all of that. It makes it really easy to deploy screens wherever and whenever you want. So let's see just how easy this really is. We take an ordinary monitor. We connect a Ndiyo to it, usually using the VGA connection. We plug the Ndiyo into the network and we connect up the power. And it's ready to use. And of course, we can connect multiple displays to a single PC. So here we have an Ethernet Ndiyo. It's driving this screen. We have another one behind here which is driving this one, and they're both being used as extra displays for this PC. They may be right next to the PC, that's the easiest thing to demonstrate here, but because it's a standard computer network, they can be as far away as you like, a mile away if that's useful. And despite the fact that these are separate endpoints on the network, our software makes them appear in the Windows control panel simply as extra displays, so we can use them just like any other monitor or graphics card. Again, this Ndiyo is a standalone device, but it's just as easy to embed directly into the back of the display, and the network connection can be wired or wireless.
So that's a bit of a much longer presentation. I'll show you a couple more clips later. We had three real design criteria when we were doing this. One was that the Ndiyo deals in pixels, because pixels are the lingua franca of display systems. And if you can make something that works fast enough just with pixels, rather than higher level semantics such as fonts or ovals or whatever it may be, then you're not tied to a particular platform. And we normally drive these from Windows machines or Linux machines, but you could potentially do so from Macs or PlayStations or central heating systems if you wanted to. Anything that has the ability to send out some data on a network. The second was we kept this really simple. The hardware, well, it's clever, but there's not a great deal in here. And this is quite deliberate because we wanted eventually to get to the point where this might be a single chip just embedded in the back of monitors. And the cost of adding an incremental user to each machine then would be pretty much negligible. It would be the cost of the display, keyboard, and mouse, but that would be it. And the last thing is we made this network agnostic. So that used Ethernet, but in actual fact, any type of connection would do. And for DisplayLink, the customers that they came across in the early days were chiefly interested in connecting not using Ethernet, but using USB. I've got a little clip here which will give you an idea of the performance of this thing. I apologize for the bit of a sales pitch in here. This was not my script in the first place.
This version of the Ndiyo connects to the computer using a standard USB 2 port, which can be found on all current laptop and desktop machines, and it connects to the monitor using a standard VGA lead here. So let's see how easy this is. This USB cable is connected to the Ndiyo driving this display. I plug it into the computer, and my extended desktop appears. So using USB, I can easily add as many displays as I want to this machine, even though it's a laptop. And as you can see, the performance here is really very good. Just like using a standard VGA cable and graphics card, but so much simpler. Now personally, I quite like working like this. I have my web browser on the left, I've got my calendar on the right here, and I've got the document or spreadsheet or whatever I'm working on here in the middle. I can deal with much more data at the same time like this, and my extended screen area makes me much more productive. The performance of the Ndiyo is such that we can achieve high quality video playback on it. Now, I may be biased, but to my knowledge there is nothing out there which can compete with it either on price or on performance, and certainly not on both.
But you get the idea. It makes it really easy to add extra displays to any machine. And in the past, if you wanted to do this, you could do it with an ordinary PC. You could add extra graphics cards in there. If you were happy to take your PC apart, you could install extra software drivers. You could put it all back together and hope it all worked. And if you thought it was difficult under XP, you should try it under Vista. And whereas now, you can just plug these things in through either the Ethernet or a VGA cable. And so DisplayLink found some customers for this, and you can now buy this technology in various forms. So Top left here is a docking station made by Kensington. This is a sort of port replicator for your laptop. In the old days, you would plug this in with one USB connection and you would get Ethernet and audio and a USB hub and so on. Now you can also get video out. There's a VGA on the back of it because it's got a Ndiyo inside. This is a USB to VGA adapter being sold by IO Gear. And Samsung have recently announced a monitor, the 940UX, which has a VGA connection, a DVI connection, and a USB connection, and you can choose which one you want to use. So DisplayLink went from strength to strength. They got 2 rounds of VC funding. They've got about 45, maybe even 50 employees now, and they're basically becoming a chip company. They're building the silicon that will make this really easy and much lower cost to do. And various big names other than these are also signed up to make use of it, which is good stuff. So at this point, I made the unwise choice, unwise financially anyway, to go back to Ndiyo. And meanwhile, back in the shed, Ndiyo had sort of been on tick over for a bit because we hadn't actually had this hardware. We'd been waiting for the Ndiyo stuff to become available, but we were just starting to get a trickle of these things now, and so I wanted to go and see what we could do with them. And we did some trial deployments in Bangladesh and in South Africa of using this Ndiyo hardware to share PCs.
This is Soweto, South Africa. Here, as in most parts of the world, the mobile phone is playing an ever-increasing role in people's lives. For those who don't have a phone of their own, though, community phone shops like these can provide a solution. Run as small businesses by local entrepreneurs, they consist of a set of payphones which are connected to the mobile phone network and so can easily be deployed in homes, shops, even in converted shipping containers. In conjunction with the GSM Association and the local service provider MTN, Ndiyo is installing 2 trial systems in Attridgeville, a township on the outskirts of Pretoria. We want to see whether the mobile phone network can also be a good way to provide internet access to customers in these locations. Providing a set of internet-connected PCs for customers to use, however, would be prohibitively expensive for many of these businesses, and this is where an Ndiyo system can make a big difference. Ndiyo uses robust, low-cost devices known as Nivos to allow several users to share a single standard PC. Each Ndiyo provides connections for a keyboard, screen and mouse, and is connected to the PC using a standard Ethernet network. We also use the Linux operating system, which supports multiple simultaneous users and has 0 licensing costs. The PC talks to the outside world using a mobile phone or data modem connected to the high-speed Edge data network. We hope that by sharing a single PC and data connection between several people, entrepreneurs like Forte Mtimkulu will be able to offer new services to his customers, and that access to the web, email and instant messaging will become possible and affordable in places where it never was before.
So that gives you the idea. One of the fun things about working for a not-for-profit technology organization like Ndiyo is it's very easy to get publicity for it. And people love writing about us, and we've been in everything from Slashdot to The Economist and everywhere in between. We've been on the BBC multiple times, partly because whenever they talk about Nicholas Negroponte's $100 laptop project, they say other groups working in this area include Ndiyo, and so we get free publicity. Thank you to Mr. Negroponte. It's the kind of publicity actually that money can't buy, and this is an interesting thing when you are a not-for-profit, but you know that this is going to have to be commercial in the long run about how you make that transition. We get into places at the moment where, you know, frankly, we would never get if we were just selling a product. Things moved on. We have a new version of the Ndiyo, which is even smaller and cuter. This is a bit smaller than a floppy disk, for those of you old enough to remember those. And, but now we have our old problem again. Because Ndiyo is a not-for-profit organization, and it's been running so far on a couple of very generous donations, but that money's going to run out in a very small number of months' time. And we need to find a way to continue this work. Now, I could go round cap in hand to various donors and foundations, and I'll probably need to do this, but I'm also a strong believer that if something like this is ever going to actually make any noticeable impact on the world, it has to be commercially self-sustaining. And simply selling Nivos from our website just doesn't work, sadly. The numbers don't add up. And so this is a bigger topic which I've just started to think about, and I don't have the answers here, but a kind of plea that we might all think about this a bit. I don't know how things work here in New Zealand, but my experience in other countries is that there is a big divide between what we think of as social work, as charitable work, as not-for-profit work, and what we think of as business, as venture capital, as business development initiatives for everybody, for government funding, and for investors as well. And I'm wondering if there's some way we can blur this distinction. I'm thinking about when we first started this, when we got into Ndiyo, we didn't do it because, you know, those people who had money didn't get into it because they could make more money this way. Those of us who had some time didn't get into it because we really wanted to work for a charity particularly. We got into it because we felt we wanted to do something of real value in the world, and if we were successful, then commercial opportunities might come along, as they have done with DisplayLink. And if we failed, as a friend of mine put it, at least we were doing something that was worthwhile failing at. And so I'm wondering if we can somehow bridge a little more the way we fund social activities and business development activities. If we can persuade investors that rather than making lots of money during their life and then giving it away when they're retired, that actually during their lifespan they invest in perhaps slightly more risky ventures, or ventures which have a different timescale, different size of returns perhaps from the usual startup organization, but frankly are worthwhile failing at if necessary. And this is also important because kids come out of college inspired by these kind of issues now. They care about AIDS, they care about the environment, they care about poverty. And how are you going to get the best and the brightest kids to come and work for your company, for your government department, rather than going off and working for Google or Weta Digital? Because frankly, government IT often isn't very sexy. But if you can inspire the kids by having some clear social message here, some clear benefit, something that they're really doing to make a difference in the world, because maybe they're not going to make very much money, then perhaps this is a good way to get hold of the best talent coming out of the universities. We've certainly got people at DisplayLink and at Ndiyo who could have had more profitable jobs elsewhere, could have had a variety of other jobs elsewhere, but who have come to us because they buy into the message of what we're trying to do here. But I haven't got the answers to that yet, and so what we're doing in the short term is another company called Cambridge Visual Networks, formed about a week ago, and the idea here is to try and create stuff that's based around the underlying Ndiyo architecture. Maybe doesn't look like Linux on the desktop for internet cafes, something that'll perhaps be a bit more palatable to organizations in the developed world, but will, as part of that, help the development of what we need for Ndiyo, help get this stuff produced in larger quantities and get it to the people who need it. And roughly speaking, what I want to do is I want to do the fun stuff around this. Because visual information ought to be fun. We're very visual animals. We started, painting on the walls of caves. It's the highest bandwidth link into our brain, and we're very inspired by all kinds of things visual. And now that we're starting to get to the point where this visual information doesn't have to be tied to the PC that sits under your desk, you can, if you want, put it around the walls of your museum. You can put it in the windows of your shop. You can put it around your house. We can start to think about the way we deliver information, perhaps in very different ways. An example I like to use is in the Ndiyo office, we have a clock on the wall, just an ordinary clock. And when we want to know the time, we don't think, which of the display devices around here has a time mode that I can put it into to find this bit of information I need, we look up there, because that bit of information has a geographical location in our lives. The time is there. I think as we start to be able to deploy displays, I think as we start to be able to devote them to particular applications, this will be quite an interesting change, that certain bits of information, we will just know where to look for them because they're always there. Maybe the traffic information for your route to work may always be by your front door, and you'll just glance at it as you go out and you won't think twice about it, rather than having to fire up a particular web page on your PC, and so forth. I think also that there are some really interesting architectures that are made possible by this kind of stuff for the future, and I like to use the example of lights, table lamps, ceiling lights. When you want light around your house, you somewhere have to have a fuse box, and you somewhere have to have a generator, but you don't want those right beside the light. You want them in the basement, or the cupboard under the stairs, or the other side of town. And I think this will be the same with information as well. We will want to put information in particular places in our living environments, whether it be offices or retail or homes, but we may not want the computer right there beside them driving it. And we really oughtn't to be limited in our ideas of how we build IT systems, in our ideas about how we build companies, or in our ideas about how we do good things for the world by the way we had to do them in the past. Thank you.
We've got a couple of minutes, so are there any questions for Quentin?
That depends how many you'd like, sir. This is ballpark, but roughly what I say is, I tend to tell people, if you want one, they cost about $200 US. If you want 1 million, they cost about $20 US. And it's purely down to building them on scale. This is one of the big problems, actually, for not-for-profit organizations trying to do something like hardware, is this is highly dependent on the size of the batch we build. So if we actually made 10,000 of these in one go, they'd be so much cheaper than at the moment where we produce some 50 at a time in the UK. But we don't have the money to make 10,000 of these. And so we need to, there's a chicken and egg problem here of getting going. We need to find organizations who are willing to put in large orders for these and to understand how the pricing will work. And frankly, we don't have the resources at the moment to either get that ball rolling as well as we should. But fundamentally, eventually, it'll be, as I say, a chip embedded in the back of the monitor, hopefully. And so the incremental cost of adding an extra user after you've got the monitor, keyboard, and mouse will be $5 or $10, but that may be a little way down the line.
You managed to emphasize the advantages of the technology for both the save the world side of the equation and also the commercial side. Can you just comment on some of the more innovative or really unusual uses that you've heard back from the people that are using them?
Well, one thing about this which has proved to be more important than we expected is that it is very low power. So a normal PC is about 60, 65 watts, plus the monitor. You've got to have the monitor anyway. This is about 2 watts. So it uses about 1/30 of the power of a normal PC. And one of the things that means is, in some countries in particular, you can actually, the amount you save in not buying PCs when you go for these is actually dwarfed by the amount you save in your electricity bills over about 2 or 3 years. But secondly, if you're making kind of really unusual networks like solar-powered networks, then that makes a huge difference in how much you have to invest in solar panels in the first place, and in, of course, the ongoing costs, or in some countries, in the amount of sunlight you need to actually drive it. So that's one example of this kind of stuff. I can think of more, but yes, the electricity thing is something that surprised us. It actually turns out to be as important as the cost issue in many ways.
I'm just curious, with 5 laptops in the house and lots of teenagers, always got a home market for ideas and stuff like
I think the home market will be big. The classic question people tend to ask is, can you do wireless? And the answer is yes, we can do wireless, and there are some, and in fact this is the area that DisplayLink is starting to move into. The reason we settled on 100 megabit Ethernet, which people sometimes have around their homes, but not so much at the moment, is that that's about the level at which you, if you do the software right, you really can't tell that you're on the other end of a network. This works just fine over wireless, but you start to notice a kind of slight performance degradation. And the last thing we wanted was that people would be sitting there tapping their fingers thinking, I wish I had a real PC. This has some very nice benefits around the home. So one of the things, you can do all sorts of fun stuff, right? If you've got a network between the thing that produces the pixels and the thing that displays them. Like you can reroute them at short notice. You can cut off that stream when you want the kids to go to bed. You can monitor it remotely if you want to and see what your kids are looking at. And actually in the classroom this is nice as well. You can take what Johnny's doing on his display and project it up here. Or you can say, now children, I need your attention, and go bing, and everybody's screen goes blank. It's wonderful. So I think there is potential very much for this in the home. I mean, apart from the fact these things are just a lot more robust than your average laptop. If you drop them, they don't tend to complain. Another nice thing about these is that they're stateless, in the sense that nothing important, almost nothing at all actually, is stored in here except the frame buffer. So there's I think it's still true to say there's less than 1K of code in here. And that does UDP stack and DHCP and so on. It's quite a challenge. But there's no important information. There's no configuration. These things you plug on the network and then something talks to them. And what that means is that if you pull the power out and plug it back in again, you can carry on working where you left off. So that has, again, great benefits in situations where the power supply is maybe unreliable. As long as you've got the PC protected, perhaps with a UPS or something, you can often get away without these things being protected, and that may be useful if you want to move them around your home. You might have monitors. I think more monitors ought to have handles on top. I'm surprised Apple hasn't done this yet. You ought to be able to just pick up a monitor, go and put it over here, turn it on, and carry on working, and you'll literally be the same place halfway through the sentence that you were when you switched off. Anyone else?
Time for one more question.
Can a local user plug in a USB drive or your personal?
At the moment, we don't do that. So there are some real limitations with this at the moment in its current form. One is that there's no USB. These are PS2 keyboard and mouse at the moment. That bit's easy to fix. To do arbitrary USB peripherals is rather harder, because then you have to start having USB drivers, and it gets hard to remote those over the network and so on. But it is something we're going to do. But I think keyboard and mouse and USB storage will come very soon. The other thing this doesn't have at the moment is audio. Again, not difficult to do. We just need to find the time and resources to do it. But that will be in the next version, which will be less than a year, I hope.
And a smart card reader, please.
Smart card reader? Right. Well, actually,
High
we have plugged other things onto this. I mean, it's amazing what you can do with PS2. We've got, I found a barcode reader, which you can plug in, and it just goes in as a keyboard wedge between the keyboard and the thing. And this was wonderful, actually. I thought, I wonder if that would work. We never tried plugging anything else into an Evo. So I got one on eBay, and I plugged it in here and brought up Amazon's webpage and picked up a book and scanned the barcode on the back, and the book appeared. And because you can type in the ISBN number basically in the search thing. The search thing even has the focus when you go to the page. I had to do absolutely zero software, and I had a lovely demo of this as a sort of point of sales or information terminal. We've also done swipe card readers and so on. So you can do quite a lot, even plugged into their touch screens potentially, even with a PS2 interface. But it would be very easy to modify this to do other kinds of peripherals if we wanted.
Okay, thank you very much, Quentin.
Thank you.
Last question.